this world. Thank you so much for joining us for our introduction to networking. We are very, very excited to be working with Distech Controls and to have Robert Lassinger from the tech support team with us today, as well as our own Optigo's Dave Cousins, our Director of Product Development. Welcome, you guys. Quick run through here. The objective today is to really help all of you who work in the operational technology world, the building automation world, to get a better understanding of IT and especially the language around IT, so that when you're in those conversations about design and how this whole system is going to work together, you're better equipped and you're able to be knowledgeable about what people are saying. However, as we got deeper and deeper into this topic, we realized there's a lot of different things. So we're going to go through today, we're going to start by talking about network layers and what they are, and then we're going to go into those different layers. So network access, all the things that encompasses, internet, and transport and application layers. Again, because this is a lot of information to cover in an hour, we realized that we actually need a lot more time to cover this. So we're going to go through that entire agenda today, and we're going to talk about all the different pieces and what they are. But we're not going to dive deep into how to program things, what's the difference in Subnet, that's 255 and 254. We're not going to get into those really nitty-gritties because we just don't have time. We are, however, going to be doing 4 more webinars to get into those. So you will see here, we're going to be doing one all about the network access and dig into those topics, internet layer, transport and application. Now we're finally going to do a 5th one, pulling it all together, designing a network. I'm not going to talk more about that because we want to get into the content, but if you want to register, we'll send more information out afterwards, or the link is up here. So without further ado, I'm going to pass it off to Robert and Dave to talk about network layers. If you do have any questions throughout all of this, please feel free to put them in the chat box, and I will make sure that we get them answered at the right time. Dave and Robert, take her away.
Great, thanks a lot. So first of all, I just wanted to say one thing. You know, I've been in telecom 20 years, and I don't know nearly enough about networking. I'm always learning. There's always a new topic. You'll find the same thing no matter how knowledgeable you get about any topic. There's always another topic to learn. So today we'll go over as many of the high-level topics as we can. But there's always going to be, you know, something to go deeper on. Always going to be something interesting to learn. So keep on learning, and we'll try to help you along that path. So I want to start with this diagram. Really, networking and your mail service are very similar. What we want to be doing is sending packets or frames, which you may have heard those terms before, which are essentially an envelope with a letter in it, and you want to be sending that from one location to another. In networking, it's exactly the same. Every packet has a payload, which is essentially the letter, and it has an envelope, which is essentially the header containing the source destination addresses. So, and Rob will go into a bit more detail on the layering, but if you think of, say, FedEx, for example, you can get an envelope from FedEx which contains a letter, which has an envelope which contains the letter itself, which is the payload. So you can nest one envelope inside of another, and that's used in networking as well. We'll get into those details. Also in networking, as well as in your mail service, you've got kind of local versus regional versus worldwide transport, and we'll talk a bit about that as well.
All right, so you guys have probably heard or seen something like this before, a network model, and the one you've probably heard about the most is the OSI model. But for what we're doing in this class or in this presentation, I should say, and what we're typically doing, we usually use the TCP/IP model, just because it's a little easier to break down and a little easier to relate to a controls installation. Both of these are valid, and you'll frequently hear IT departments or people referring to the OSI model and saying things like layer 2 or layer 3. But in reality, these models don't describe how a system is actually physically built and how you set it up. They're just a good way of visualizing the network and having a way to discuss different portions of it or different components. So We show this here just so you have an easy way to relate in case you're accustomed to using the OSI model and you want to kind of see how we're breaking it up for the purposes of this presentation and the future ones. So we're going to be discussing the application, transport, internet, and network access layers in this presentation. And you can relate those to the OSI model on the left if you're more familiar with that one. But I want to stress that these are just network models, and these don't define how your network is built. This is just a great way for us to discuss it and have some common ground when we're referring to something like layer 2, which I'm sure most of you have heard, or layer 3. So that's why we show this here, and that's kind of where we'll be going from this. Okay, here we show two networks. One is an MSTP network going through an ECY controller, which is the one on the top. The bottom one is an MSTP network going through an ECBOS or a JACE. The top one is MSTP going through an ECY, which is, in this case, the ECY is just acting as a MSTP router. And the same is really happening when you tie an MSTP network to an ECBOS or a JACE, which is on the bottom. And the reason we show this is a lot of you are probably familiar with MSTP networks and that architecture where you might have one BACnet network with 30 devices and another BACnet network with 40 devices, and they're being routed up through some other component, like a JACE or an ECBOS or an S1000, to get to the network and to get to other BACnet networks. So the architecture we're going to discuss going forward is very similar. There's a lot of common ground. I mean, really, in a BACnet network, you have a subnet. You end up having a gateway, which in this case is your ECBOS or your S1000. And we're going to have those same concepts at the IP level. So I wanted to just show this here to kind of make you understand that you, in a way, you're already familiar with IP architecture, and you're doing it whether you're doing LAN or BACnet or even Modbus. You're actually doing that already, and you're accustomed to it. So we're just going to kind of take that up a level and discuss it at purely the IP level. But don't let the terminology scare you, since you're really already doing it. It's very similar to this, and we're just going to kind of expand on those concepts. And if you think about it that way and try to relate it to what you know, you're going to find it's pretty easy, actually. So from where we need to go with the controls role.
And so expanding on that same concept, this is kind of a diagram that would be used by IT professionals to talk about their networks. If you look at the dark blue circles, you've got a layer 2 network. So this is something maybe the size of a building, you know, with a handful of devices in it, say 50, and you want to keep your networks, your layer 2 networks at a nice small size so they're manageable. You don't want to have thousands of devices in there. And then if you go up to the next layer, at layer 3, you create a network of interconnected layer 2 networks. So this would be, for example, like a campus for a university or for a large company, maybe a series of buildings. And so you're able to route traffic in between the different layer 2 networks via the layer 3 network. So that you can actually then increase the size of your network together without increasing its complexity. And then what we've got there is the internet. There's really a couple of ways of going through the internet. You can just go out through a public IP, or you can go through a VPN to another network. And you need a gateway to do that. Gateway is just a type of router, and it's basically set up to talk out to the internet, and anything you can't route within your layer 3 network, where it doesn't know where to route it, it sends out through the gateway. So this is just another way of looking at the same thing. So what you have there, you can see if we go backwards, you've got the internet, you've got your gateway, which has a firewall on it. Then you've got your layer 3 switch, and that is allowing you to have interconnectivity between your layer 2 networks. And each of those switches, you can see, for example, if you go down from to the right from the layer 3 switch, you've got a layer 2 switch containing a whole series of BACnet devices on it. So a layer 2 switch, again, is just something that will connect a bunch of devices together into a small network. Layer 3 switch then brings that up a level to connect a bunch of small networks together. A gateway allows you access out to the internet, so you can route through the internet to other networks out there. I didn't mention firewall before, but a firewall is just a thing that will allow access or deny access for different services through that router. And the VPN is a more secure tunnel through the internet. So these are some terms that we'll be using quite often, and you'll get to know them and understand what they do as we go on.
And I think it's worth noting here before we move on a little bit too that, and even if you look at the previous slide, if we can go back one more there just for a second. In this one you see, in this one you have a layer 2 network going up to a layer 3 network so that information can be routed between these two layer 2 networks. And that's very similar if you look at something like MSTP, where you might have a bus going up to a JACE or an EC boss, and then the EC bosses would be talking to each other at layer 3 in this case. And you can apply that same concept here when we're talking about IP devices going to switches and then onto routers and things like that. So like I said, you're probably familiar with this in a lot of ways, and just we're now kind of applying terminology to things you probably already know.
And at the same point, if we want to go back to the analogy of the postal network, you can have your local area, maybe your neighborhood, versus your city, versus sending across the country. So it's the same concept of going up the layers.
All right, network access layer. This is the easy one and the one that's probably my favorite. This is your physical connection to the network. However you get there, this is it. Whether it's wireless or with an RJ45 or however you manage to get there. There's some odd stuff out there that I've used in the past, but your network access layer is how you get to the network. And in this case, we show wireless and Ethernet, which are the two most common for this discussion. This is our preference, of course. This is Ethernet, and this is the one we'd like you to use the most. Ethernet, the advantages are the ports are obviously more common. It's faster than wireless. There are some exceptions to that, but generally speaking, a wired network will be faster than a wireless. It's typically more secure just because it's a physical connection. So if somebody has to actually get to a network jack and plug in to gain access. So that it's security just in the sense you have to physically be at the device. And it has greater stability. It's less likely to go down, unless you're working on a construction site, in which case it might be the opposite. But generally speaking, wired is better. Some disadvantages are it's expensive to install. Obviously, pulling copper through a building is going to be expensive, and wireless kind of will help you there, but there's some downsides to that we'll discuss in a second. And obviously, it's not supported by mobile devices. So if you want to set up your device with an iPad or something like that, this isn't going to be able to facilitate that. So, Wi-Fi. So lowered cost of install. That's really probably the biggest reason we see people trying to implement and use wireless. It's compatible with mobile devices, which is of a benefit depending on your site, and has better accessibility for technicians and other trades, which is pretty often. And we use this, but a better use for this is typically you try to limit where you have wireless to where you either one, you can't get a wired connection, or two, you need that kind of accessibility. Something's in a roof or in a space or above a hard lid where you can't get to it. And so you might want wireless at that point. Disadvantages, it's almost always slower than wired. And it is subject to interference. Anybody who's done a wireless network has probably experienced that quite a bit. And obviously it's less secure. But since you're transmitting out there, depending on how determined somebody is, it's going to be accessible to someone who's determined enough. And so you have to be very careful how you implement wireless and what it's connected to after you install it. But the most important thing is all of these are the same from a layer standpoint. For the discussion we're having, they are effectively the same. They all have to either go through an access point or a switch. But at the end of the day, when it comes to layer 3, they're all having to go the same direction. So we just want to stress that the discussion we're having here applies to both, and any discussions you're having with an IT department are going to apply to both, but you may have some very specific security requirements for wireless that don't apply to wired. So.
All right, so managed and unmanaged switches. Really the question here is how big is your network and how much control do you want over it? Let's say you have a home setup and you've got 5 or 6 devices. An unmanaged switch is fine for that. You can easily connect your printer and your PC and your TV if it's a internet-based TV. No problem. Easy to control. It's cheap, and you won't have to worry about it because there's hardly anything ever goes wrong. However, if you're in a very large network, let's say you're controlling a building or a campus, you're going to have a lot of devices. You're going to have a lot of issues happen. So you're going to get really poor control and not very much information that you can get from those unmanaged switches. This means that troubleshooting problems becomes an issue. Trending, understanding what your network's doing, that becomes an issue. So on managed switches, you basically get the basic function. You get segregation and isolation. And what that means is, for example, using VLANs, we'll talk a bit about that later, you can separate, say, all of your security from all of your HVAC and isolate them so that certain people can manage one versus the other. Additionally, maybe if you have a building that has multiple companies in it on different floors, you can actually segregate those as well and separate the traffic. So in addition to that, we get port security. So we get things like overload protection and traffic blocking and MAC address locking so that you can have only specific devices in them. So a lot of managed switches provide that capability as well. They also log a lot of information about what's going on in your network, and you can go back and have a look at that data, analyze it, look at trends, look at where your network's getting overloaded versus and where you're seeing trouble in your devices. Usually, and talking from an Optigo point of view, we have an easy to use interface that allows you to go in and manage those switches via web interface. And that's a very handy tool for people that are managing a number of switches across their network. So again, Pro, we have a lot of control, a lot of information, and when you're dealing with a large number of networks and devices, you definitely want to go this direction. They are a little more expensive, but the return on investment is huge when it comes to the amount of time it takes to fix problems and being able to trend your network.
Yeah, one of the issues I did want to cover is a lot of the issues we see here at Distech when working on big sites or trying to help you guys out are we see these light commercial or just unmanaged switches that are being daisy chained together because you might have a switch every 3 floors and you obviously don't want to have to pull up 10 Cat5 cables up through 4 floors or something like that. So you tend to daisy chain these together, and that's where a lot of the problems start. So if you have 25 devices or 20 devices, we understand it's typical application for an unmanaged switch. But once you start to get towards 50 devices, or you start trying to have a switch for every floor or combine these things up, that's where you might need to consider an aggregation switch to bring them all together, or consider just buying a bigger, like a 24-port managed switch so that you can isolate each floor. Another benefit that you don't see with it, even if you use subnets, when you put in unmanaged switches, it's basically the same network. You can group your controllers by subnets, and a lot of you do that by floor or as a way to segregate the building. But really, if it's an unmanaged switch, it's the same network. So any problems you see are going to be there regardless of your subnet. With a managed switch, you can have a VLAN per floor or multiple VLANs per floor. You could say port 1 is going to be floor 1, port 2 can be floor 2, and so on and so forth. And your problems, if you have any on that floor, are going to be limited to that VLAN. So while being a little bit more expensive as far as your initial installation, it's going to be far easier to troubleshoot. And for large jobs where you're starting to get to 100 or 200 or 1,000 devices, it almost becomes mandatory to really get the kind of performance you're going to want out of the network. So I like to, at least, I know it's tough to put a fixed number on these things, but once you start getting to 50 IP devices and above, you really want to kind of consider a managed switch. That's a good point to kind of really look closely at what you're going to get out of that, because there's a lot of benefit from security and segregation and isolation, which will really help you out and make for a cleaner job. We end up helping on a lot of jobs where we have 24 stories and all of the switches are daisy chained, and then they get back to a supervisor, and packets start dropping, backnet devices going offline, and the network becomes unpredictable because you don't know what those switches are going to do. They don't drop the same packets every time, so they perform. So there's lots of issues, not to mention single points of failure. If you have 4 or 5 switches daisy chained up, if one of those switches goes, you're going to lose everything. Whereas with a managed switches or aggregation switches, you can segregate the building so that you don't lose everything in one shot. So, and the Optigo switches aren't. It's one of the reasons we like them is they're very easy to set up. They're intended for you guys to set them up. A controls guy or an installer who has a little bit of knowledge to really set those up. They don't need an IT guy to configure a VLAN. These are fully designed for you guys to set up, and we're going to support you on them. So if you call us, we're going to be able to help you set up those VLANs. Whereas with any other managed switch, if you have an IT guy, that's fine, or an IT department supporting you, that's great. But otherwise, we can't really offer much support once a network is set up and it's using third-party equipment like that. So it's just worth noting that keep an eye on that when you're starting to daisy chain these switches together, and maybe reevaluate whether because if you're going to spend hours and hours troubleshooting, you'll definitely exceed the cost of a managed switch pretty quickly. So worth noting.
And speaking of VLANs, let's talk a bit about that. So again, if you look at what this diagram shows, there's really 3 VLANs set up. And again, we're going back to that segregation and isolation bit. So the blue switches there are the edge switches, which all these devices are connected to. And as you can see on the left, we've got 3 devices from VLAN 10 and 1 device from VLAN 30 connected to that switch. And then at the central aggregation switch and network controller there, we are connecting all of those together. If you also notice at the bottom on VLAN 30, we've got 2 more devices which are connected to a different switch. So what a VLAN allows to do is put a secure trunk through that central system, connecting just those devices together. So on VLAN 30, you'll have a secure capability of all those devices being located on a single VLAN that are not accessible by anybody that's on one of the other VLANs. And so, for example, let's think about security cameras. If you want all your security cameras within a building put on a single VLAN so that only people that are only security cameras and only devices that collect the information are able to access that information, you can do that using VLANs. You can also do this using subnets, but there's a problem with that, and that's that all the subnets are accessible throughout the entire network. So you won't have that security. And then the second problem with that is that if you create another subnet, you'll have to add another switch to the system. And so the more subnets you create, the more switches you add. As you can see here, we've created 3 different VLANs, and we haven't had to add any additional hardware to do that. So it scales quite nicely. So you get a really nice scalability and a really nice security aspect to what you're looking at here.
I think, can I add, if you don't mind, Dave, I want to add one more thing to that.
Yeah.
From a security standpoint, a lot of us coming from a world where we did LAN or MSTP, security was a physical thing. If somebody couldn't get to the JACE or the EC boss or the supervisor, we really didn't have to worry about it because you weren't worried about somebody getting directly on an MSTP trunk and making trouble. I mean, occasional contractor would do that to you, but generally that wasn't an issue. With IP devices, that's a big issue because once you put a backnet IP controller out there and you have some AVs and BVs exposed, how do you stop someone from writing those? Even if it's by mistake, how do you stop someone from broadcasting information, time sinks, and other things? And generally, even so, it's easy to make mistakes. It's hard to track down. If all of you have had a controller where somebody's writing to an AV and you can't figure out who's writing to that AV because it's on an MSTP trunk, or you had a controller that was peer-to-peer to it. With VLANs and managed switches, you can troubleshoot those. You can track down that communication, and you can also isolate. You can say only this device on VLAN 10 can talk to this device on VLAN 20. So your VLANs don't necessarily have to be broken out by floor. You can break them out by device. You can have them grouped in ways that make sense for security. So VLANs give you a lot more options, and in the IP world, you're going to need those options for security, because if you have a big network, it's hard to secure it. Granted, if it's 10 devices and a little switch in a panel, then if somebody doesn't get to the panel or somebody's not physically there, it's not a big issue. But in a big building with IT closets and things like that, and people moving wires and plugging things in, it's a big problem, and it's hard to track down issues. So VLANs offer you a lot more than just a way to break your network apart. They give you a lot of security and a lot of features. And for troubleshooting, even if you were to call someone like me and have me come into your network and help you troubleshoot, having these VLANs set up would make things considerably easier and faster. So it's worth considering from a support standpoint and a long-term security standpoint. You know, your customers rely on you when you install IP controllers. They're kind of trusting you to provide a secure environment, because they don't always know that, they don't understand that these backnet points are just available on the controller and can be written to by anybody on the network, right? So they're just going to open up the VLANs if you leave it up to them, and they're going to assume it's okay. What could go wrong? And they don't understand. So you need to either explain to them or take it in your hands and set up the VLANs yourselves so that you can secure them. And the Optigo switches will allow you to do that. All right, here a lot of you have probably seen this. If you're not familiar with this on the left, this page, you've seen it on your Windows network settings or Mac or wherever. It's very common. And we're going to talk a little bit more about each of these on the next slides. But what you see here is your IP address, your subnet mask, your gateway, and your DNS. And here I just want to stress the really important ones. Your IP address, obviously, every device needs to have a unique IP address on your subnet. That's just, all of us probably know that at this point if you're working with IP devices. But we need a way to resolve that MAC address. And that's what the IP address gives us. The subnet mask is just a way for us to logically group these devices. So 255.255.255.0 allows for us to have 254 devices, right? Well, 255 really, but 254 actual devices. And we'll talk more about the gateway and the DNS in the coming slides, but gateway is just basically your way to get out of the network. So anything that you can't communicate to on a subnet, or that you have a routing table for, will go through the gateway. So in this case, if I only wanted to communicate to 206.33, which is maybe the next controller, I would only need the subnet mask. I wouldn't need a gateway and DNS if I'm just going peer-to-peer between those two controllers. So that's really why this slide's here, to make stress that the important ones are subnet mask and IP address. Gateway and DNS are in fact optional in the controls world, and in some cases you may decide to intentionally leave them out depending on the type of network you set up. And the next slide should help you decide whether that's the case. All right, DHCP. This is one we have the most calls on for devices, and we send out our controllers with DHCP enabled, and this often gives us issues. So DHCP at its very basic is your controller will come online and it sends out a broadcast, and it asks, I need an address. That's basically what's happening. And then a DHCP server is listening to those broadcast requests, and it responds. And it says, well, you're on my network, and I'm allowed to hand you an address, and here's your address. And it chooses out of a range that's pre-configured. So somebody set up a DHCP server and said, well, you can hand out these 50 addresses. And so it hands it out, and then the DHCP client, which would be your controller, it accepts it and sends a response saying, I've accepted it, so that the DHCP server does not hand it out to any other controllers. And that's at a fundamental level, that's basically what happens. It can get a lot more complicated when we start talking about static leases and things like this. Dave, did you want to cover that one? Or we
sure.
That on the
I could talk about that a bit. Absolutely. So in terms of how a device is given an IP address, there's a number of different ways. One of the simple ones is a static IP address, in which case you don't need DHCP, D being the dynamic aspect of it. And so you can just, on a device, give it a specific IP address. Now, that means you're managing it yourself, which means you got to make sure that it's unique and it's not assigned elsewhere in your network. So it's kind of taboo, I guess, for the most part in larger networks because you want to have a dynamic aspect to it. However, there's some services that have to have a static IP address, and you'll find out about those services, when you're actually creating your network. The DHCP server, you can have reserved IP addresses, and you can have dynamic ones. And the dynamic ones, as Robert was saying, are leased out. And you can release the same IP address. So, for example, if your IP address expires after a week, and your device goes in and asks for an IP address, it can actually say, "Give me the same one that I just had," and so that's a reserved. Otherwise, it's purely dynamic, and it'll get whatever IP address the DHCP server is giving you.
I think I'll just touch on one more thing there that we probably forgot to put on the page. A lot of times it's very tempting to give every one of your controllers a static IP because it's a lot easier. You set a static IP and now you know where that controller is. And so the temptation is there to just give it a static IP. The issue is that wasn't a big issue in controls when we had 4, 5, or 10 IP-based devices. That was pretty easy because if you had to go change them, you would simply just go log into each one and change it. Not a big deal. But now that the number of IP controllers you can have on a large job can easily exceed 1,000, if you leave them DHCP and you use static leases with a DHCP server, when it's time to change them, you can change them all in a short period of time because you can set the reservation time. So you could, if you needed to change, say, the subnets, or you needed to change it to from a 192.168.1 to .2, you could then do that, and then all of the controllers, when they requested their new DHCP address, they would apply the new value, and you wouldn't have to log into a single controller then to fix that. So it's worth noting on large installations, really want to stress you really want to use DHCP on large installations, because otherwise later when you have to change the addresses, you're going to have to spend a significant amount of time to do that.
Yeah, and just to bring it back also to the analogy with the postal service, your IP address is basically your street address. So you might move around from one address to another, but you'll still have an address. And that's how the Postal Service finds you. Same situation here.
And just because this is a big topic, I'll just also jump in on the DHCP part. When you put in a static IP as well, let's say if you were to do static IPs all over the place because you're used to it, and that's what typically we've done in the past, just remember that if you're going to go there and troubleshoot, and anybody else is going to troubleshoot, and they put in an IP address that's already taken, you pretty much just, dramatically kind of messed up the network at that point. So this is also a big reason why you want to use DHCP, and the reason why we've enabled DHCP on our product.
For those of you wondering who that bodiless voice just popped in, it's Sam Sharma, also from BizTech Controls, who's online to help out and add his 2 cents. Thanks, Sam.
We'll be adding Sam's cell phone number to the presentation later, so just call him directly if you have any questions.
Personal and work.
Yes, of course.
Good one.
Subnets. One of my favorite topics, one of the most hated topics. Subnets, how you break up your network. And before we start on this, we're just going to cover this briefly, but I do want to stress that breaking up your networks with different subnets, that's a valid way to break up networks. It makes sense to group controllers that should be talking and broadcasting to each other in logical groups. And it's more efficient, but it's not a replacement for VLANs or some other means to break up your network, whether you're using VPN or VLANs, typically with a managed switch. But on large installations, subnetting alone will not solve your issues. So it's very important to keep that in mind. But what we're going to cover here is just the basic description of a subnet and what you might run into. So typically, most of you will see most subnets as 255.255.255.0, which is a Class C. And that's what you run into typically in your house or in a small network. And the notation you see here, which is one of the things we want to cover, is called a CIDR notation, which is classless interdomain routing. And the only reason we show it here is because you might get handed a set of ranges by an IT department, and they may list them like this. So there's easy ways to convert these online, and you can get like a subnet mask cheat sheet, which will tell you what all of these are in a little chart. But if you see this, like this, the first one you see there where it says 13 hosts, where it says 192.168.1.0/27, that's just referring to the subnet mask. So in this case, a /27 would be the subnet mask 255.255.255.224. And that's about as boring as it sounds. So do yourself a favor. If you ever see that, look up the table and just use the table. Don't even bother trying to guess it. But when you put this in your computer, that is what it's describing is that network. So it's saying the network at 192.168.1.0 will be broken up into groups with 13 potential hosts in this case. So that's why we see this frequently and we get calls on it. So just remember, this is called CIDR notation, and you can look it up with a subnet mask table, and that will tell you what that / number means. But it's always, or you can always obviously ask the IT department, but if you're putting this in a computer, in this case, it would be 192.168.1. whatever address at 255.255.255. In this case, it would be 224. Would be the last year's subnet. And this is complicated, but doing this will allow you to have a lot better control of your network, because then only broadcast traffic between those controllers, they'll share broadcast traffic, but it should be isolated outside of that using VLAN. So it's a complicated topic, and we are definitely going to go much more in depth in later presentations with subnetting. We're going to go over how to do it and a lot of different strategies for doing it, whether you're building a site with an unmanaged switch or you're building it with a managed switch. We're going to cover both, but I wanted to specifically cover the notation one because we get that question a lot. And the last thing I'll stress is keep your subnets as small as possible. So a lot of you will get to a site and you have, say, 301 controllers. And so the first thing you do is you're like, well, a class C won't work, so I'm just going to go straight to 255.255.0.0. And that's really not what you want to do. You really want to look at a subnet table and narrow down your subnet to actually encompass realistically the number of devices you'll be using. You don't want to have 46,000 possible addresses when all you have is 301 controllers, right? So we really want to keep subnets as small as possible. That's the rule of thumb. And like I said, we're going to cover it more, and you're always welcome to call technical support, and we will help you set the exact subnet you would want for your network. But there's some really helpful tables out there, and even some calculators that you just plug in what you want, and it'll tell you the exact subnet you should use to design your network. So, but we'll go more in depth because it's a big topic, but it's definitely worth being careful looking into. So don't just indiscriminately assign 255.0.0.0 or 255.255.0.0, because there's implications there, especially if you're going to have other people and other devices like security cameras and things on your network. There's some bigger implications there that you won't be aware of when you open up your network like that, especially since we do broadcasts with UDP on BACnet, and so you can have some big problems if you're not careful. So keep in mind, subnets need to be as small as possible.
All right. So I'll briefly go through what a gateway is and what NAT is. So a gateway is a type of router that allows access to the internet. And it's very simple. Anything within your network that you cannot route locally is going to go through the gateway. A lot of devices will be given a default gateway. That's something you'll configure within them, and that will point you from within your network to the gateway that has access out to the internet. Some networks don't need a gateway because they're local and they don't have access to the internet. So this is an optional piece. But if you are internetworking across the internet to other sections of your network, then we would put a gateway in. NAT, so that's the network address translation. So sometimes you're given a small set of IP addresses. If we go back to the previous, we were talking about, sorry, you don't have to go back, but you could have let's say you get a set of 16 IP addresses, but you have hundreds of devices. So what NAT will do is it'll map a private IP address allocation to public IP addresses. And I won't go into detail on how it does it, but it does use specific ports on that single public IP address. So you're able to use, and typically like 10.10 or 192.168 are private IP addresses. And these are not, those IP addresses themselves are not routable outside the internet. And outside the internet, you're seen as 206.12.0.100 port something. So anything that's routed inside and outside the network will use that external IP address. This gives you two things. One, you can now have as many IP addresses inside your network as you want, so you're not limited. And number two, it also means that internally you've got private IP, which nobody else knows how to access. So you get security as well out of that. All right, and so I won't go into a lot of detail here. This is actually a topic upon itself here. You've seen the symbol about routers. Routers can mean many things, but basically what they do is they take incoming traffic on one IP address and they send it out on another port to some other place. And it knows how to do that because it has a routing table. A routing table, without going into details, there's many algorithms on how to create them and maintain them. Is basically just something, it's a map essentially that says where to send a packet. The one interesting thing from a backnet point of view is that routers do not pass broadcast packets. Now that's actually really interesting because most of backnet is broadcasted. So what's been created is, the BBMDs will turn all the broadcast traffic into unicast and send them out through the router, and then the router is essentially tricked into sending that broadcast traffic. And then on the other end, you'll take that unicasted packet and broadcast it within the other network. So basically, we're just tricking the router into sending our packet and broadcasting it on another network. And just to give you an example of a route, so if I was starting on a device on the left-hand side, there's a network which is described by 10.10.88.100/16. So there's a set of IP addresses associated with that network. So let's say we're at 10.10.88.100, that's our device, and we need to send a packet out to the internet. We've set up a default gateway on that device, 10.10.0.254. So right away, that network knows that it can't route it internally, and it needs to send it out through the default gateway. And that comes out to the router. And at this point, the router does a lookup in its table, and it sees the destination IP address is 192.168, sorry, is that right? Okay, 192.168.11.20, and it knows where to send that because the mapping has told it that 192.168.11.1/24 goes out on the upper right-hand side. And so that goes out to that network, and that network knows how to route that to the specific device. So it's all about the routing table. And again, the thing of note here is that they don't do broadcast, and people in IT hate broadcast because if you think about the internet, there's thousands of routers out there, and if they're all broadcasting, it's going to flood the internet. So it's actually a good thing from an IT point of view.
We'll try to move through this one pretty quick because I know the material gets a little dry at this point. Some of these topics aren't as fun as others, but DNS is a really good one. Everybody uses it. This is a domain name. So basically what we're doing here is we are resolving a name to an IP address. And without this, nothing's going to work. And most of the time, if you take this out of your controller or your computer, you're not going to get anywhere because most of our navigation is done by domain name. We don't go to the IP address for Google or the IP address for wherever we're getting weather. We typically use the name. Even if it's a really long URL, it's still being resolved to an IP at some point. So it's important to note what that is. And the reason for that is you may or may not want that in a controller. It's in an IP device. And it's also important from how you're configuring your network. So, but DNS, if you don't have a reason for your controller to go to the internet, if there's nothing it needs, you shouldn't put that entry in there. That's something we find frequently. If there's a controller that is only doing backnet IP, doesn't need to get weather, doesn't need to update its time out on the internet, doesn't need to do any of these things, then there's no need to have DNS entry. But if you're going to be sending emails or getting weather reports or doing a time sync to something on the internet, then you're definitely going to have DNS entries. It's the only way that it'll work. So but it's worth noting here, the reason we put this here is just because you don't have a DNS entry doesn't mean you can't get to the internet. It just simply means you can't resolve names to the internet. If you know the IP address for where you're going, you're fine. You can just route traffic that way, and you can go directly to the server you want by IP, and it'll work. But so that's the important thing to remember about your domain name service. And your DNS server can be local or it can be remote. A lot of you might know that 8.8.8.8 is Google or some of the other common ones used out there, or you may just have one local to the site you're on. So, but all the same, you're going to need one to resolve a domain name, except some special circumstances where you can do local stuff on your machine.
And the last item in this section is really about how you get from one network to another network across the internet. So there's really two ways of doing it. Pretty much every network has a firewall, and you can poke a hole through that firewall and allow traffic. And in some cases, that's actually a really good idea. And you can allow, for example, here, allowing port 47808 can exit the network, but not enter. So that's just one example of a rule you can put on a firewall. But that means that anything with any service within the network can use that port. So it's a little bit promiscuous. VPN, on the other hand, allows you to share services across a network. So basically what it does is it will allow you to have a local IP address on the other end of the tunnel. So it's an encrypted tunnel which allows you the security across the internet and allows you to appear as if you're part of that other network. And then you can share services between them. So if you're just looking to share a service or access a very specific service, you're going to want to go VPN. If you're looking to allow everything to send traffic out or to send traffic into your network via a port, then you're going to want to use the firewall rules to allow that access. But those are the two main ways to get in and out of your network.
All right. This is a pretty easy one, and we are going to go much more in depth in this in later presentations. But these are the two ones you will most commonly hear, TCP and UDP. And for BACnet, we use UDP, and for most everything else, we use TCP. And the big difference is the one that's going to match you is UDP will let you do broadcast, and TCP does not. And so with BACnet, we need to use UDP, and that's the main reason. So if someone would ask you, what port do you need open for communication, obviously you're not just going to respond 47808. They may not know, and they'll just assume it's TCP. So you need to make sure you stress it's 47808 UDP so that they understand what you're looking for. And it's worth noting, one of the other benefits to TCP is TCP will, if a packet is missed, TCP will try to deal with that. UDP doesn't. So if you send a packet and if it doesn't get there, the protocol just doesn't care. It'll just keep going. And that's great for video or for BACnet because, as you're well aware, if we send a temperature update and it doesn't get there, it's okay because it's going to get polled or it's going to get broadcast again at another interval. So within reason, it's okay to lose a couple packets. It's not going to hurt anything. Obviously, we don't want that to happen too much, but it's worth noting that TCP is a better protocol in some regards, but UDP works much better for what we're doing with BACnet.
All right, so now we're all the way up to the application layer. So sitting on top of all those layers is the different services and applications in your network. You'll see a lot of familiar ones here, HTTP, your web browsing, SNMP, where you get alarms, SMTP, where you're getting your email, et cetera, and you see BACnet is another one of those protocols. And so these all sit on top of what we've talked about so far, so the transport and networking layers and so forth. And so these are really, if you go all the way back to the beginning when we talked about having an analogy with the Postal Service and the fact that we have letters inside of envelopes, this is really the letter. So this is the payload of what's going to be sent back and forth. So in BACnet, that might be like a temperature sensor piece of information, and that's wrapped within the protocol where we're sending an envelope from A to B, which might be within another envelope, which has an IP address on it, and it can get routed, and so forth. So this layer just sits on top of it, and this is where all the services happen. I don't want to go into too much detail on this today.
So that's most of the content. I have a couple questions here that I'm going to ask you guys. As you know, we talked a lot about controls and networks, and so this is really our way of collaborating these two worlds. That's kind of what we do at Optigo, and obviously DHCP is a great controls vendor, so that's why we're both here today. But a question for you guys, on a single managed port, is there a limit to the amount of devices that can be connected, or better yet, is there a limit of IP addresses a single port can have?
I like that question. I would have asked that one. Dave, that one, I'll leave that one up to you.
I don't think there is necessarily, because you can actually chain things together. I would say no.
But would you say that it's going to be, for the most part, going to be limited by the hardware you choose to install?
Yeah, for sure.
Okay, so that would be your limiting factor, is what hardware you chose to install would dictate how many devices you could be put behind a port.
You can't limit it by IP addresses, though. It's more what the hardware can support.
Right.
Okay. Another question, which I just lost here, was discussing, it was in the DNS, when you guys were talking about DNS, can you limit the access so that it's only what's entered in the table?
On a computer, yes, that's easy to do with some work. On a controls device, no. So you'd have to take care of that at the DNS server. You could do that there. You could lock down what that controller is allowed to resolve, but that would not be done at the controller level. So if the controller has a DNS entry, it's going to ask whatever it wants to know from the DNS server, and if whatever the DNS server gives it, it's going to trust. It's just going to take. So keep that in mind. On a computer, it's different. On a Windows machine, we could do something there, but typically speaking, most of the world kind of leaves it up to the DNS server, and that's where companies like to have their own DNS server, because they will not allow you to resolve some addresses. If they don't want you doing certain things or going to certain sites, that's exactly how they secure their networks. They'll just take that entry out of the DNS server, and it won't resolve it for you. So you'll say, I want to go to my poker site, and all of a sudden you don't know the IP of it. You try to get there, and it doesn't come up because it doesn't let your machine resolve the IP. So, so from a controls perspective, no, there's not much you can do on an Eclipse controller. Once you put the DNS address in there, it can go wherever, it can resolve whatever name it wants and goes where it needs to go.
Okay, great. So thank you again. Please go and sign up for our next couple webinars, and we will see you very soon. Thanks again, Dave and Robert.
Thank you.
Thanks, everyone.